So now that we've defined some controller types, we can think about the process as it's being controlled. So in other words, a process where the state variable y is being measured and we are taking control action on that whole system. So we want to close the loop. We want to imagine the case where we have a controlled process. So from the previous development, we said our control action has a controller transfer function, and that's multiplied with an error. Then if we go back to our original formulation on the process itself, we said that our response was equal to our process transfer function multiplied with the control action taken. So now we've done all the work of proposing a framework for our control action. So we can just substitute this u here. And so now we can say y equals gp, which we had before, now times gc times the error. So now we've gotten away from this unknown u function to something that's of interest to us, which is the error, which is the difference between the set point and our current state values. So yeah, the abstraction of u now disappears. And so we have this, this nice form, and we can see y's on both sides. So we can group out to y. So y on the left-hand side, and then we can take across this part is GPGC times minus y. So when we take that across, we would group out a GPGC. And left over on the right-hand side is GPGC times YSP. So that's left over on this side. And so if we wanted to write y over YSP, then we would say GPGC over 1 plus GPGC from the left-hand side. And so now we have a new form of transfer function. And this is where we are looking at the response with respect to our desired set point. And we call this now our closed loop transfer function. And we recognize here that this closed loop transfer function actually contains open loop functions in it, right? If we go back here, we can see that we have an open loop part. So we call this GPGC the open loop transfer function because it's the process itself times the control action. So we think of that as G open loop, and this whole thing is G closed loop. So we can say G closed loop is equal to y over YSP, which is equal to G open loop over 1 plus G open loop. And we can think now of using things like the poles, and that's what we'll do next. How do we use what we know about the poles and that we want to avoid positive real parts as part of our stability criterion?